Now let's talk about document IDs a bit more and how you can go about making them useful and unique. This is actually a very large discussion which we'll only introduce in this particular lesson, but it should be helpful. So first, how do you go about choosing a document ID in the first place? Well, because it's not enforced by Couchbase. You have the opportunity to express a fundamental aspect of your application in this choice. So the document IDs, the keys, as far as Couchbase are concerned, can be any value up to 256 bytes. It simply needs to be unique within its bucket. So you could be predictable about it. You could use keys that are some pattern combination of name, email, IP address, or any other values that somehow relate to the entity being created. It could also be unpredictable. You could use GUIDs, UUIDs, etc. Although it's worth stopping to consider that if you need to know the key in order to get the document, having a consistent way to figure out the document ID is probably a good idea. Now, you could also embed typology information. That could be useful for an application as well. It's what we're modeling in this particular set of labs, where we take the type customer and precede it simply by convention with 2 colons, followed by some predictable value. In this case, first initial, last name, and then an arbitrary number. Well, that's kind of interesting. We could include arbitrary numbers in this somehow in order to ensure uniqueness when our predictable values could be duplicative, because there's probably a lot of Joe Smiths out there in the world now, aren't there? So this is where counters come into play. You can use a counter to enforce uniqueness. So how do you create and use a cluster-wide counter in Couchbase? Well, once again, bucket to the rescue. The bucket has a counter method that allows you to specify an ID, which is the name by which this particular unique counter will be known, and then you can set parameters. So this is going to create or update the specified counter document when you call it. You can set the increment value by how much should it change. As you would expect, it's going to increment by 1 by default. You can also set an initial value if you want something other than the default. You can set a timeout and time unit, as you've seen on all of these bucket methods. And it's going to return a JSON long document, a particular subtype of document that will contain the incremented or decremented value. In code, could look like this. You could implement a method getNextID that's going to determine what particular document to access based on a pattern that you've baked into the application. In this case, we're taking the particular local domain type, getting its name, lowercasing it, and using that as part of creating or updating a particular named ID. The convention being used here is counter : and then the type name. So you would see a document would be created or updated in the bucket, counter : customer in the case of a customer type. And so by invoking the counter method and then passing in some increment and initial value, if appropriate, as it is in this particular example, it's going to return the next incremented value as a JSON long document. Then I could return that value. In our case, again, we're returning it, this time with the type name with the double colons appended, followed by the content of this document converted to string for the sake of concatenation here, which would give us back, for example, the customer : followed by an incremented value, as you see below on screen, customer : 100, 101, etc. Of course, this is only one way you could go about it. Creativity is endless with programming, but at least it's an interesting example to consider as you determine how you're going to do this yourself. Would it ever throw an exception? Well, sure, things go wrong. So as we've said, you can put a specific timeout on this method call and capture it, and all of the usuals are available here as well. In our demo and lab, you'll go in and implement and use a cluster-wide counter using the general approach that we've just looked at. In your code, you'll go to the getNextID method, and you'll implement it in the way that we've talked about on the slide, where we're using the type name in a particular convention so that our counters are set up to be unique based on the underlying data type, which is an approach that you may find useful as well. GetNextID is then used throughout the application where needed. Go ahead and jump into the lab. And when you're done with this particular lab, we hope you come back. We have one more lesson to go where we'll talk about, as we've previewed a few times, the whole idea of check and set or compare and swap, which is how we implement optimistic locking in Couchbase.